Hello friends and welcome to another tutorial on Geeks4Geeks. In this video, we are going to understand the program which prints boundary nodes of a binary tree in anti-clockwise fashion. First, let us take an example. In this example, the boundary traversal will be 20, 8, 4, 10, 14, 25 and 22. Now, let us have a look at the algorithm which will assist us in printing the boundary traversal of a binary tree. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 to function print boundary. Hence, root will point to 1. Since root is not null, we print it. Hence, 1 will be printed. Now, we call the print boundary left function with root's left child passed as parameter. Hence, in the print boundary left function, root will point to 2. Since root is not null, we check if root has a left child. As 2 has a left child which is equal to 4, we print 2. Now, we call the print boundary left function with the left child of 2 which is 4 using a call stack. So, root will now point to 4. Next, we check if root has a left and a right child. As it does not have both left and right child, we do nothing as it is a leaf node and we have a separate function to print the leaf nodes. So, we finish printing the left boundary of this tree. Now it is time to print all the leaf nodes. So, first we call the print leaves function with the left child of 1 which is 2 passed as parameter. Hence, in the print leaves function, root will point to 2. As root is not null, we pass the left child of root to print leaves function using the call stack. Hence, root will now point to 4 which is the left child of 2. Again, we pass the left child of 4 which is null. Since root is pointing to null, we return to the previous call. Now we check if node 4's left and right children are both null. As it is true, we print node 4. We pass the right child of node 4 which is also null. Since root is pointing to null, we finish execution for node 4. Execution for node 2 is resumed and now we check if the left and right child of node 2 are null. Since it is false, we pass the right child of node 2 which is 5. Hence, root will now point to 5. Since root is not null, we pass the left child of 5 which is null. As root is pointing to null, we return to the previous call state. Now we check if the left and right children of 5 are both null. As they are null, we print 5. Next, we pass the right child of 5 which is null. Hence, root will point to null. As root is pointing to null, we finish execution for node 5 as well as node 2. We go on to the print boundary function and now pass the right child of 1 to function print leaves. Hence, in the print leaves function, root will point to 3. As root is not null, we pass the left child of 3 which is null. Since root is pointing to null, we return to the call stack. Now we check if node 3 is a leaf node. As node 3 does not have both left and right children, it is a leaf node and we print 3. Next, we pass the right child of 3 which is null. Hence, root will point to null. Since root is null, we finish execution for node 3. We continue with the print boundary function and now pass the right child of 1 to function print boundary right. Hence, in the print boundary right function, root will point to 3. We check if root has a right and a left child. As node 3 does not have both left and right child, we do nothing and finish execution for this program. Hence, we have the final boundary traversal for this binary tree. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.